far is we've looked at solving, we've looked at drawing the unit circle, we've looked at stuff off the unit circle, we've looked at trig ratios, etc. Now what we're going to do is we're actually going to look at what a sine graph looks like. So when you type in a line, you guys know what a line looks like. You know what a quadratic looks like. You know what a cubic looks like, right? A quartic, quintic. All of those you know from polynomials. But you don't know what a sine or a cosine graph looks like. So we're going to look at the basic ones. Now your unit circle actually has all the information in order for you to draw one. Okay? Now if we're going to look on here, we have 0 to pi to 2 pi. So what we're actually splitting these up by is pi over 3. And I'll explain what, or pi over 6, sorry, and I'll explain why after. But what we're going to do here is this is going to be pi over 6, and this is going to be pi over 3. This is going to be 2 pi over 3. And we're going to work our way around the unit circle, excluding the 45s, just because it's not set to that scale, and I'll show you why later. 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 5 pi over 3, 11 pi over 3, 2 pi. So I basically picked, 11 pi over 6, don't know what I put. 11 pi over 6. That's going to bother me. So I basically just used all of the arms off the unit circle and all the 30 and 60 reference angles. The only ones I excluded are the 45s. Now we know on the unit circle, what can we pull directly off from the unit circle? Quickly. What are our coordinates? No. What do our coordinates always cover? Calgary Stampede. What do they always cover? Cos and sine. So all of the x's are cos. All of the y's are sine, right? We're looking at what right now? The y equals sine theta graph, right? Do we care about the x values at all on the outside? No. We only care about the angle and the height of the y's, because the y's are the sines. We agree? So the angles are your x values along the bottom, and the y's are the sines. So if I start at 0, what's my y? 0. So at 0 radians, my y is 0. So I have a dot here. So my sine equation, the basic y equals sine theta equation, starts at 0, 0. Okay? Then I move up to pi over 6. This is my pi over 6. What is my y? So I go to, this is going to be 0.5, this is going to be 1, this is going to be negative 0.5, this is going to be negative 1. So at pi over 6, I'm at 0.5. So the unit circle goes in a circle, correct? And there's coterminal angles that can keep going, right? We can find a coterminal angle with any angle on the unit circle, right? We just add 360 to it, or add 2 pi. Or we can go in the opposite direction. We agree? So 0 to 2 pi just covers one part of the sinusoidal equation, but it's going to keep going. It repeats. It's periodic. It does this onwards for life unless I restrict your domain, right? Because sinusoidal functions just keep going, repeating, 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 repeating. Because there's coterminal angles, bless you, to every angle. At pi over 6, or sorry, pi over 3, I'm at root 3 over 2, correct? But in order to graph root 3 over 2, you need to turn it into a decimal. Root 3 over 2, I think, is 0.866. So I'm going to go to about 0.866, somewhere about here. And then I go to pi over 2. What's my y? What's my y at pi over 2? It's 1. The radius of the unit circle is 1. I feel like I'm starting with a blank slate, which is a little scary, guys. A little scary. Um, 2 pi over 3. I'm at what on the y? Root 3 over 2. It shouldn't be hard. You can look right on your unit circle. Okay. So 0.866. At 5 pi over 6, what am I at? 0.5. At pi, what's my y? 0. Now what's going to start happening with my y's? Remember the unit circle is slotted on a Cartesian plane. They're going to go negative. All right, so 7 pi over 6 is at negative 0.5. Four pi over 3 is at negative root 3 over 2. Three pi over 2 is at negative 1. Oops. 5 pi over 3 is at negative root 3 over 2. 11 pi over 6, oops, is at negative 0.5. And then we go back up to 0. Now this does not look like a crazy straight V's all over the place. It's like a curved mountain, not a peaked mountain. More like a hill, yes. Now the key thing to see here is it's symmetrical about the x-axis, right? And it's periodic, so what would happen? It would keep going this way. It would keep going that way. Correct? Forever. Onwards, unless the domain is restricted. Correct? Just keeps repeating itself. So, what's the period? The period is how long it takes it to repeat itself. That's what the period is. How long it takes to repeat itself. So how long does this sine graph take till it repeats itself? 360 degrees, or 2 pi, right? And how do we know that? Well, we start at 0, we go past a max, past a min, back to 0. It's going to start repeating itself, is it not? Plus, it's a full circle. It takes 2 pi to repeat itself, doesn't it? So the period of the sine theta graph, the period is 2 pi or 360 degrees, depending if it's in radian or degree mode. What's my domain? Infinite. What we can see is 2 pi, right? But is that where it stops? No, we just stopped drawing it there. But it could keep going negative this way, and it could keep going positive this way, so your domain is, you can find an x value for everything unless I restrict the domain. That's why the domain has to be restricted all the time. If it's not restricted, you have infinite answers to your solution. So when it's restricted, it's a lot easier. So the domain is XER in set notation, or negative infinity, positive infinity in interval. Now, what's your range? What's the lowest your y goes to? -1, so does the unit circle, correct? And what's the highest it goes to? Does it include those values? -1 and 1? Yes, because it maxes there, mins there. So interval notation is really easy. -1, 1, square bracket. Because there's y values between there, right? They're all squeezed in between there. Set notation isn't that bad. You're going to do y such that all my y values fall between -1 and 1, correct? So I'm going to start off with my lowest first. -1 is less than or equal to y is less than or equal to 1, YER. So it's saying all the y values fall between -1 and 1 inclusive. So you always have to start with the low one and then do less than symbols both times. So -1 is less than or equal to y is less than or equal to 1. It's stuck between them. Yes. Yeah. The amplitude is half the difference between the max and the min. So some people figure out the amplitude by memorizing the formula. But honestly, if you can just count from the min to the max how long it takes and divide it by 2, you have the amplitude. The amplitude is always positive. Always, always, always. Because it's a distance. It's how far. Half the distance from the min to the max. So how far is the distance from the min to the max? 2. I go up 1 to 0, 0 to 1. So there's a distance of 2. So my amplitude is 2 divided by 2, which is 1. It's half the distance. You could fill it into this formula. The absolute value of 1 minus a negative 1 divided by 2, which is the absolute value of 2 divided by 2, which is 2 divided by 2, which is 1. But the moment you have to memorize formulas is the moment you can mess up a formula. It's better to understand. The amplitude is just half the distance from the max to the min, or the min to the max. So count your distance from the bottom to the top and divide it by 2, and you have your amplitude without having to fill it into a formula. Okay? What's the y-intercept in this case? Where does it cross the y-axis? At 0. So 0, 0. That's a lot easier to write than the x-intercepts. The x-intercepts are at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and then this way, right? 0, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So you would like to write 0, 1 pi, 2 pi, 3 pi, dot, dot, dot. Negative pi, negative 2 pi, negative 3 pi, dot, dot, dot. That's how you would like to write it, representing all of them. However, that's not how they write it. Okay? You have to write a general solution unless the domain is restricted. So when the domain is restricted, it's actually nicer. If they restricted it between 0 and 2 pi, your answers would be 0, pi, and 2 pi. You'd be done. Okay? But if they don't restrict your domain, you have to give every x-intercept that exists. So you have to give the general solution. How you do that is you do theta equals, and then this is always the smallest positive angle. So what's the smallest positive angle in this case? 0, technically, right? So we'd write 0. And then plus how long it takes to repeat. Or how long to get to the next one. How long does it take to get to the next x-intercept? Pi. And the next x-intercept? And the next x-intercept? Pi. So it keeps happening at pi, right? So plus pi n nei. And I'll explain why we do that. Pi n nei. The reason why we write pi n is because what we're saying is every time you multiply by a pi by n, you will get one of the solutions. And then behind it, I said n is nei. What the heck does that mean? That means n is an element of the integers. What are the integers? The integers are non-decimals, positive and negative. So 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Those are integers. So what I'm saying by writing this is I'm saying you can find solutions the whole way along if you just take 0, add to it pi times any integer. So let's try it out. Let's try 0. 0 is an integer, correct? So 0 plus pi times 0. 0 plus 0 is 0, one of our solutions. Yay. Let's try positive 1. 0 plus pi times 1 is pi, one of our solutions. What if I try negative 1? 0 plus pi times negative 1 is negative pi, and negative pi is going to be one of our solutions. So that this writing encompasses every solution possible, not just the ones we can see. Okay? Now, did that 0 affect it at all? Did the 0 affect it? No. So you wouldn't actually have to write the 0 in this case. They would write it as just pi n nei. You only skip out the smallest positive angle if the smallest positive angle is 0, right? Because if the smallest positive angle is 0, if you add 0 to anything, it doesn't change it. But if it's any other thing, you have to add it. No, but the multiple choice won't be there. Like 0 won't be an option. Because adding 0 to it doesn't affect it. Yep. Yeah. Okay, now we're going to type in our calculator. Go y equals sine theta. I'm pressing the sine button. The moment I press the sine button, I have to pick a mode. What mode are we going to pick? We want to compare it to what we have. So what are we in right now? We're in radian. Yep. So we're going to put it in radian mode. The theta button is just x. If you look at the x button, it says xt theta n. It just means that any variable that's in there, you can just plug that in. You're okay. You didn't have to apologize. No, I meant you didn't do anything, so you wouldn't have to apologize. Okay. Okay, so what we're going to do is we're going to go to our window, and we want to make our window the same as this one. Because the best way to tell if you have the right equation is to make your window the exact same as the window you have. Okay, so what's our x min right now? 0. What's our x max? So go 2 pi, and it'll turn into a decimal, just let it go. What are my ticks going up by? No, look at the very first tick. We're doing x, not y. 0 to pi over 6, right? So we're going up by pi over 6, and you'll see why in a second. And it goes through that. So your x scale is going to be pi over 6. What's your y minimum? -1. What's your y max? 1. What's your y scale? 0.25. Now, think about this. What's the only thing that's going to change if we change this to degree? The x values. The x values are going to completely change if this is degrees. But would the y's change at all? No, the y's aren't affected by degree or range, just the x's, right? Degree or range. Degree or radian. I don't even know where I was going with that. Y being range. Okay, so press graph. Do you get the exact same graph? Yes. Now, change your mode. That's sweet, guys. Change your mode to degree and press graph. Your fun is stopped. So, why is your calculator not liking you right now? Right. So 2 pi is approximately 6.28 something, right? So right now, degrees. So right now you're saying that your window is from 0 to 6.28 degrees. So it's not going to give you very much of a graph, is it? So your window is actually in radians. Now, what happens is when you press the sine, cos, or tan button, you need to decide what mode you need to be in, okay? Now, say you press graph and you're like, man, I've done everything right and it just doesn't show up. There's a last-ditch effort to help you, okay? Remember that when you go and change your window and you can't get anything to show up before, your teacher would tell you to go zoom 6, set it back to the standard window. Maybe you have like your max and mins flipped. Well, what you can do is once you press your mode, so in this case, I picked degree. I pressed graph. It didn't work, right? I'm ready to cry. I don't know what to do. Okay? We don't want you crying. So you're going to press zoom. And instead of standard, because the standard window is just -1010, which isn't helpful for very much in a trig graph, is it? Unless it's a word problem. Go zoom 7. And at least at the bare minimum, it will get you a trig window that's degree mode now. Okay? Now, I always say to you, this is your last-ditch effort, because if it's a word problem and it's a Ferris wheel that goes to 80 meters, this window is not going to help you. It'll help you so that you can possibly see something, but you're still going to have to adjust your window to help. But if you're stuck and it's doing some like crazy window that you know doesn't look like a sine or cos or anything, don't cry. Try zoom trig first. See if it can help you out. Then you can cry. Okay. So I want to show you how I came up with the actual ticks here. If it's degrees, everyone's really good. They take their degree, it's 360, divided by the number of ticks, and they know what it goes up by. If it's radians, we have tiers. We don't want tiers. It's actually really easy to do radians. Okay? This is the whole cutting you guys from crying thing. That's what I'm doing here today. Guys, no tiers. Okay. So what we do, and we're going to pay attention so we're not lost and crying later, and then you'll be like, well, I'm crying. I don't know how to do this. And I'll be like, remember that day when I told you no tears? This is that day. Okay? Don't make me go back to that day. So we want to know what the ticks go up by. And I told you what they go up by, so this was easy. However, a sound test, I don't tell you. That's a problem. So if we find pi, which is right here, always look for pi. And then you want to see how much pi is split up. Well, if you count the number of ticks between 0 and pi, you know what each of those ticks is split up by. So if I count the ticks, it's 1, 2, 3, 4, 5, 6. So each of these ticks is just pi divided by 6, right? So this one would be 1 pi divided by 6, would it not? And then the tick between there is another distance of pi over 6, is it not? So now the next one is 2 pi divided by 6. What's 2 pi divided by 6 reduced? Pi over 3. Then this one's 3 pi over 6, which reduces to pi over 2. Then 4 pi over 6, which reduces to 2 pi over 3. 5 pi over 6 is 5 pi over 6. 6 pi over 6 is pi. What's great about this? You just keep going. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6. You do have to reduce them, though. There's luckily a few that you don't have to, but 12 pi over 6 is 2 pi, and you could keep going. So all you need to do is find your closest pi, figure out how many ticks, how much times it's cut into, and then you got the scale. Really easy. Okay? All right. What does the cos graph look like? So the cos graph is set up the exact same. So we're going to have pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, 2 pi. And now we're just going to use what off the unit circle? The x values, right? So at 0, what's my x? 1. Then here, my x is actually root 3 over 2. Then here, my x is going to be a half, or 0.5. Here, my x is 0. Here, my x is negative 0.5, because I'm on this part of the quadrant, and all x's are negative in quadrant 2 and 3. Then here, I'm negative root 3 over 2. Negative 0.866. Then here, I'm negative 1. Then here, I'm negative root 3 over 2 still, because x's are negative on this side. Then here, I'm negative 0.5. Negative 1. Whoa, 0. Doing y, sorry. X is 0. Then I'm back to positive because x's are positive here. 0.5. 3 over 2. And back to 1. What is the period of this graph? How long did it take to do the circle? 2 pi or 360. And this one is the same. It's max, past a min, back to a max, and what's going to happen? I'm going to start repeating myself, correct? So it takes 2 pi till I do the full period. What's my amplitude? My amplitude is half the distance from the min to the max. So it's still 1, because it's 2 to get me to the min to the max. And I divide by 2, so it's 1. My amplitude is always positive. What's my domain? XCR keeps going on forever. What's my range? Oops, square bracket. -1, +1. So far, everything's the same, isn't it? My y-intercept, however, is 0 and 1 now, not 0, 0. And my thetas, my theta intercepts, or my x-intercepts, because it's in the same spot as theta, right, where x would be. What's my smallest positive? Theta equals my smallest positive x-intercept. Pi over 2. Plus, how much does it take me to get from pi over 2 to 3 pi over 2? Pi, right? Because you're just starting here. Go to 3 pi over 2. It's 180 degrees, which is pi.